Hiya! So in this video, we're going to be talking about rotations in two dimensions. In other words, if we kind of recall what happened last time, we had a linear operator. We were defining orthogonal linear operators, and we ended up with this kind of matrix here. I guess this one here, 1.22. So 1.22 basically gave us a rotation matrix, and I said we'll see this in an example. So let's look at an example to kind of see how this rotation matrix works. So remember, we have to start off with some orthonormal basis, E1, E2. And we're going to start with some vectors. So here we're going to have some vector x1, x is equal to 2E1 plus E2. And we're going to let phi be pi over 2. In other words, I want to look at the rotation of pi over 2. The rotation, or this, sorry, pi of, this is rotation by pi over 2. So in other words, what we're saying is this linear operator should take my x and rotate it by 90 degrees. Okay, so let's look at this. So let us literally use the formula that we had before. So in 1.23 here, we had a formula, right? So let's literally, we're just going to use it. So 1.23 gives us, I guess I should do this around it. We have p of pi over 2, because that's the angle of x. That's our vector. This is going to be equal to 2 cosine pi over 2 minus sine of pi over 2, right? Let me double check, because we have x1 cosine of phi. So this is x1 cosine of phi, then x2 sine of phi. x1 is 2, x2 is 1, so we're good so far. And this is actually for E1. And then we do the same thing for E2. So here we have x1, which is 2 sine pi over 2, plus x2, which is 1 of cosine of pi over 2. E2. That, why is it 2 under? There we go. So in other words, this is my x1, this is my phi, this is my x2, this is my phi. I guess we'll put a little 1 here to show that this is really what the x2 is. Okay, so let's calculate these. Cosine of pi over 2, this is equal to, I guess we should do this. This is equal to 0. Sine of pi over 2 is equal to 1. Sine of pi over equal is 1. And then cosine of pi over 2 is equal to 0. So what do we end up having? This is equal to 2 times 0 is 0. So we have minus 1, in essence. Minus 1 of E1. Plus 2 times 1 plus 1 times 0. So that's 0. So this is 2. 2 times E2. So in other words, we just get 2E2 minus E1 in essence. So let us, so actually we have an image of this. So here I have the image. Here I have my two vectors E1 and E2. So let's look at this. We'll zoom in. Bam. Zoomed in. So I have E1 and E2. And remember my x here is 2E1, right? So I do E1 twice. 1, 2. And then I go up by E2, right? So this is my x. And then after my rotation, p of pi over 2, remember what formula I get? I get minus E1. So I have to go minus E1. And then I go plus 2E2. So I go 1, E2 is here, and the second E2 is here. And you can kind of see, so if I had my original x here, which is roughly that, you can kind of see here we have a 90-degree rotation. Yeah. So this is one choice of basis. So another thing we can kind of do is, so this is one choice of basis, right? So on the bottom here, I have a second choice of basis. And we'll talk about this in a minute. But here, if I have my E1 pointing north and my E2 to the east, so I've now changed the order, right? So these two, this is the basis E1, E2, and this is E2, E1. So remember what this is basically saying is the orientation of these two are opposite orientations, right? Because I've just swapped them. So let's see what happens. Here, so again, I have E1, E1, E2. So that gives me X. Here I have minus E1, E2, E2. And that gives me the rotation. And if I draw the original X, which is here, then you can see this is still a rotation of 90 degrees, right? But the angle, the direction we go is different. So I think 2 weeks ago when we talked about, I talked about in the review session, right? The choice of the rotation, right? The angle that we go is going to be dependent on our arbitrary choice. And this is what we mean by this arbitrary choice here. In other words, the direction we go is dependent on our chosen orientation of our basis. So our basis is really saying which direction this should go. I can either go one way or the other way depending on it. But in particular, this anti-clockwise and clockwise, this is completely determined by the orientation. So the orientation is really the orientation. The orientation is really giving us everything, completely determined by the orientation. And so the ordering of the bases is the explicit thing that tells us which direction, whether we will clockwise, anti-clockwise when we're doing a rotation. So we really saw this in this kind of thing. So we'll stop this video here. In the next video, we're going to look at the second case. So remember, the first case was when k is equal to 2m. So let's go back. The first case really was when k is equal to 2, k is even. So let us now go to the second case when k is odd. And in the next video, we'll see that these actually correspond to reflections in 2 dimensions. So I will see you then. Peace.